When you think of San Francisco, you picture the Golden Gate Bridge, cable cars, maybe Alcatraz. But lately, another landmark has stolen the spotlight, the Millennium Tower. From the outside, it's a sleek 58-story luxury skyscraper, home to tech moguls and athletes. But beneath the glamour, a crisis was brewing. The building was sinking and tilting. At first, it was just a few inches, but soon, it earned a new nickname, the Leaning Tower of San Francisco. Residents noticed doors sticking, cracks in the garage, and marbles rolling across the floor. Lawsuits flew, and the city was left asking, how could a billion-dollar building in a world-class city just start to lean? The answer lies deep underground, in the hidden world of foundations. We trust skyscrapers are anchored to something solid, but the real story is about what's beneath the surface. The Millennium Tower became a cautionary tale for cities everywhere. Residents bought a promise of luxury and stability. Instead, they got a front-row seat to a slow-motion engineering disaster. The problem wasn't just cosmetic, it was a symptom of a massive, expensive issue lurking far below. Fixing it would take years and hundreds of millions of dollars, so what went wrong? To find out, we have to dig deeper. Skyscrapers don't stand tall by magic. It's all about engineering and piles. Piles are like legs for buildings, driven deep into the ground. The strongest are end-bearing piles which reach all the way to bedrock, transferring the building's weight to solid rock. But bedrock can be very deep, making this option expensive. The alternative is friction piles, which rely on the grip between the pile's sides and the surrounding soil. If the soil is dense enough, friction piles can work, but it's a calculated risk. Engineers study the ground, do the math, and make a call: bedrock for safety or friction for savings. For most buildings this works out, but for the Millennium Tower, the choice of friction piles set the stage for disaster. The bet on the soil's strength would prove to be a costly gamble, and it all started with what was under San Francisco's streets. San Francisco's downtown sits on shaky ground, literally. Much of it is built on reclaimed land filled with sand, debris, and even garbage. Beneath that is bay mud, a soft, wet layer with the consistency of jello. It compresses and shifts under weight or during earthquakes, terrible for skyscrapers. Below the mud is colma sand, denser and more stable, but not as solid as bedrock. Many buildings use this sand for their foundations, but it has limits. Bedrock, the safest option, lies over 200 feet down. The Salesforce Tower next door anchors to bedrock. The Millennium Tower, however, stopped at the sand. The ground beneath is a layer cake of fill, mud, sand, and finally rock. Where you stop digging can make or break a building. For the Millennium Tower, that decision would have huge consequences. The Millennium Tower's engineers faced a choice: drill piles to bedrock or stop at the dense colma sand. Bedrock meant safety, but also much higher costs. They chose friction piles, stopping at the sand, believing it was strong enough. For a while, it worked. But the tower's immense weight pressed down, squeezing water from the bay mud below like stepping on a wet sponge. The mud compressed, the sand settled, and the building began to sink. Then, next door, construction on the Transbay Transit Center began. Crews pumped water from the ground, disturbing the soil even more. The sinking accelerated and the tower started to tilt, especially toward the giant pit next door. What began as a cost-saving measure turned into a billion-dollar mistake. The foundation's failure was now impossible to ignore. The city had to act. By 2016, the Millennium Tower had sunk 16 inches and was leaning several inches northwest. Residents faced plummeting home values and daily reminders of the crisis. After years of lawsuits, engineers devised a fix-a-perimeter pile upgrade. They're drilling 52 massive steel piles, each 2 feet wide and 250 feet deep, all the way to bedrock. These new piles will transfer much of the building's weight from the failing friction piles to solid rock. It's like giving the tower new legs, ones that finally reach bedrock. The project is delicate, expensive, and happening under a fully occupied skyscraper. The Millennium Tower's story is a warning. Shortcuts in engineering can have catastrophic consequences. The ground beneath our cities is complex and unpredictable. The fix is a testament to human ingenuity, but the lesson is clear. The most important work is often buried deep out of sight. In the end, what's beneath the surface matters most.